Hello, my name is Patrick Smith. Welcome to my final project video for the TechniCity MOOC. In my final project, I explored how technology can be used to improve data collection for Louisville's urban tree canopy. Research from Georgia Tech's Urban Climate Lab has demonstrated that Louisville is getting warmer at a higher rate than other cities thanks to the urban heat island effect. That is, Louisville has an increasing gap in temperature between its urban area and its surrounding countryside. The best thing that cities can do to combat the urban heat island effect is to plant more trees in urban areas. Unfortunately in Louisville, and despite several false starts, we still do not have accurate, precise, and up-to-date data reflecting the current state of our urban tree canopy. Specifically, I wanted to use my TechniCity project to learn more about the best methods for volunteer data collection for Louisville's urban tree canopy, including location, species, size, health of the tree, and the tree's planting environs. In considering the best platforms for volunteer-generated location-based data, I looked at the possibility of using geographic information systems, mobile phone applications, tablet applications, and open-source web software. I began this data collection effort by engaging volunteers in the use of paper maps for field data collection, and then I entered the information they collected on the paper maps into an ArcGIS geodatabase. In this manner, a lot of ground was covered for my downtown project area, but the process was very time-consuming, so I explored opportunities for using technology to streamline data collection. When I told people about this project, many suggested that a mobile phone would be the perfect tool, as a phone's GPS capacity could be used to collect the tree locations. But the question here is, how accurate and precise are coordinates collected via a smartphone? After discussing GPS data collection via smartphones with several professional app developers, the consensus was somewhere around 3 meters of accuracy, which several of the developers thought would work just fine for a tree app. But what I had found in the field was that there were common instances of trees being well within 3 meters of one another, so 3-meter accuracy from the actual point didn't seem that precise enough to me. As the data for individual trees are very near one another, it could be prone to error if we're depending on mobile phone coordinates. One map app developer, Michael Schnerla of Your Mapper and the Safety Crime Checker apps, thought a good compromise might be the building of a phone app where a volunteer could zoom in on a map with their phone and move the point to the correct location, which I think is a good idea, as volunteers could drag the dot to the correct location on the map, but there might be difficulties with working on such a small screen. Maybe an app for a tablet could be better, but it could be challenging to provide tablets for a large number of volunteers. Through this project, I learned that the best way to employ technology to this particular urban problem in the short term is to continue with field canvassing with my paper maps. By that I mean collecting tree locations manually in the field, but to save time, collect the points on maps only, leaving out the tree data such as height, canopy width, tree health, etc. Then I could upload the points to an open source tree mapping package called OpenTreeMap. Cities such as San Francisco and Philadelphia are already using OpenTreeMap for their own tree data collection initiatives. Login and user approval can be set up for this software, so just not anyone can jump online and edit tree data. In my deployment of OpenTreeMap, I might retain control of locating the tree points to make sure they were accurate in our study zones, but then I would have volunteers add the actual tree data to the existing points I've uploaded using their smartphones, tablets, or on their PCs. This would provide options for different types of volunteers. Since the OpenTreeMap software can be configured across many devices, people who found smartphones too difficult for use in the field could use their tablets, and people that don't have tablets could make notes and add the data using the online version of the software on a PC. Thanks so much for reviewing my project. I hope you had a good time participating in the TechniCity MOOC. 10-4, over and out.